Okay, so question number 8. What is the Lewis structure? Assuming that's PO4 minus 3. So the phosphate ion, in which the octet rule is satisfied on all atoms, show all the non-zero formal charges. And the second part, in which the central phosphorus atom has a formal charge of 0, show all the non-zero formal charges. Okay, so first let's calculate the total number of valence electrons. So a phosphorus atom has 5 valence electrons, oxygen has 6, and there are 4 oxygens. So we multiply 6 by 4. And there's also a minus 3 charge, so we add an additional 3 electrons. So this gives us a total of 32. Okay, so for the first part of the question, they want us to draw the Lewis structure in which the octet rule is satisfied on all atoms. So let's draw the phosphorus in the middle. Let's do this as A. Where the octet rule is satisfied. So if we were to draw phosphorus in the middle with all of the oxygen atoms symmetrically placed around it, then our phosphorus atom has its octet rule satisfied. And if I were to draw all of the lone pairs on oxygen, then each oxygen atom has the octet rule satisfied as well. So now they want us to show all the non-zero formal charges. So the equation for formal charge is equal to the number of valence electrons minus the number of non-bonding electrons. So these are all the lone pairs, minus the number of bonding electrons divided by 2. Okay, so let's calculate the formal charge of phosphorus. Phosphorus has 5 valence electrons. There are no lone pairs, so no non-bonding electrons. And there are 4 bonds, so there are 8 bonding electrons in total. So 5 minus 4 is plus 1. So we'll put a positive charge on the phosphorus. And we only need to calculate the formal charge on one of the oxygen atoms since they are all the same. So oxygen has 6 valence electrons. The number of non-bonding electrons is also 6. And the number of bonding electrons is 2, since there's only one single bond attached. So 6 minus 1 is minus 1. So all of the oxygens has a minus 1 charge. So this is the structure in which the octet rule is satisfied on all atoms. And for part B, in which the central phosphorus atom has a formal charge of 0. So in order for the phosphorus to have a formal charge of 0, I'm going to form a double bond with one of the oxygens. So now all of these oxygens still have a minus 1 charge because they didn't change. But now let's calculate the formal charge of this double bonded oxygen. Oxygen in the double bond. It still has 6 valence electrons. Its number of non-bonding electrons is only 4 this time. Oops. And there are 2 bonds because it's a double bond. So we have 4 bonding electrons divided by 2. So 6 minus 4 minus 2 is just 0. And now let's double check to see the new formal charge of our phosphorus. Still has 5 valence electrons, 0 non-bonding electrons. And now if we count out all of the bonds, we have 1, 2, 3, 4, 5. So we have 10 bonding electrons divided by 2. And this gives a formal charge of 0 on our phosphorus. So that is correct as well. So now let's see what the junior tutor said. They summarize the Lewis structure. And for part A, they got the same structure where the octet rule is satisfied. And for part B, they drew the double bond to show that phosphorus is now neutral. So this solution is correct.